I want to generate and render a maze. And the type of maze I want to generate is a perfect maze. A perfect maze has two conditions. One condition is there are no cycles, meaning if we imagine there's a door here, this would not be a perfect maze because we could run in a circle here. And the other condition a perfect maze has is that for every 2 points, there is a path between them. So if we imagine this is the start point, this is the end point, that we can then travel along some path and arrive at this point. And this must be true for every point. So we cannot have isolated areas like this. This would not be valid. I'm not going to do this in React. Now, why do I have React code open? This is just to embed it into another React project I have. Don't worry about it. All it does is it just calls the draw maze function, which will give it a canvas reference. That is all we need to know. So let's define our draw maze function. We already know it takes in a canvas element. And I imagine this will also take some maze object into it and be able to draw it based on this. Now what is this maze? Let's give it a type. A maze consists of cells. We saw that in the diagram, and paths between the cells. So we could say it's a collection of cells, for example, and whatever a cell is. And let's think about a cell. A cell must have a location. It should be somewhere. Let's give it coordinates, x and y coordinates. And it'll also have paths to somewhere. For example, it could be open left, open right, open top, open bottom. So let's give this an enum. And let's call this direction enum. And let's give it north, south, east, west. And it'll have a bunch of doors, which will be a direction array. And maybe this cell will have some useful, maze will have some useful information, like its height, how many cells it has, and its width. And this should allow us to draw a maze. Let's give this also a maze to draw. Let's say we just want to draw a let's draw a 2x2 maze. In order to draw this, we need first to know how large our canvas is. We also need our drawing context. And the first thing we do, let's just paint this entire thing black, just to see that we're actually doing something. Fill rect, I believe, yeah. 0, 0, and we go to width and then height. And we switch over to our screen, and yeah, it does switch the scene. Okay, we can see we have just a nice black rectangle. Let's define some constants for our drawing. Let's say we are going to draw our cells Let's think, what color would we want it? I'm just going to make them slightly off-white. And let's also draw, do we want to draw a grid? At least we want a wall color. And let's make that darker. I want my cells to be squares, so I need to figure out how large the cell inside the canvas should be. And since our width and height is not necessarily equal, I'm going to use the smaller one as the measure, so that the entire maze fits into the canvas. I shouldn't call this number. This is the size. I'll just call it size. And a cell size itself is going to be the size divided by the maximum number of cells in a row, so either height or width of a maze. So let's actually rename this to canvas. Right, because it's using D structure. Let's call this canvas height, canvas width, and we're going to use canvas width. And let's call this the canvas small side. And let's get the maze large side. And a cell size is going to be the canvas small side divided by how many cells we want to draw in this. But we also want to floor this because we don't want any weird floating point numbers. Let's just draw one cell in cell size. We expect it to fill a quarter of the screen. It does. If I highlight the canvas, yeah, it seems to fill a quarter of it. Right, so instead of drawing it black, let's draw it in the cell color. Then let's also draw the walls, which we are going to set it to the wall color. And then we're going to draw the walls. So we are going to draw them. We're going to draw 4 walls per cell. Actually, let's put this into loops. Then we can move this in here. The cell size. And I should initialize them with 0. If we look what we do now, we draw the entire plane with the cell color, which is correct. And now we want to do the same thing for the walls, but we don't want to fill the cells, we want to draw all 4 walls. How do we do that? Well, their size is 1 pixel at this point. And actually no, the height, let's draw the top line first. The width would still be the cell size. And the location would be the same. If we look at our canvas, we see we're drawing the top line now. I'm zooming in a bit, just then we can clearly see it. The bottom line would be basically the same thing, except we want to skip one of the cells. So we want to add a 1 here. And then we want to go a pixel back up because we want to be on the inside. Not here +1, y +1. We want to be in the next cell. If we look at this, we get a thicker line here because we have two balls next to each other. But at the bottom we have a line now as well. And we can repeat this for the x coordinate. And then subtract 1. If we look at our maze, we are capable of drawing a grid now. Not very exciting. But we can make these now conditionals. So if the now our cells are not indexed here. It's a one-dimensional array, so let's add a helper function. Let's call it index. It'll take in a width, an x, and a y, and it'll turn us a number. Now, we can flatten a two-dimensional array into a one-dimensional array. This would be, let's say this is 0, 0, 0, 1, 1, 0, 1, 1, 2, 0, 2, 1, with the first one being the second one being the x coordinate, first one being the y coordinate. And this would be a 2x3. We could format it like this to visualize it a bit better. And the index here can be computed by just multiplying the width with the y, because for every, to get into the next row, we must skip width many elements. And that's pretty much all we need to do. So this is just number of the rows plus Vx. So we are going to select the row y and then move to the right x many elements. And this gives us the index of our 2D array. That is our index. Then we can get our actual cell. And then if cell doors includes directions, east, or rather does not include direction north, because this is the top line, then we're going to draw the top. I'm just going to copy this code. This is south. This is the west, and this is east. Okay. Now let's add some doors. Let's say the top left cell has a door to the south, which means the bottom left cell should have a to the north. Now there are different ways of modeling this, where not every cell would need to know its actual doors. We could have a separate array for the paths, but if we look at what we rendered now, we can see the door here, the wall here disappeared. Let's also remove this wall and that wall. So this one also has a path to the east. As well as this one has a path to the east. and both of these have a path to the west. Render this, we are only left with this door here, this wall here, so we see we have a maze now. It's not a very exciting maze, but we have a maze. And next time we'll be looking at actually generating the maze.